In this segment, we will discuss 4 typical phenomena that can occur in an electrical distribution system. We will begin with harmonics. Harmonics are high frequency, current, and voltage. These stress the electrical distribution network, being that most electrical distribution networks are a stiff or low impedance system. Voltage distortion can cause distortion of control signals and stress electrical equipment's dielectric material. Current distortion increases the electrical distribution network RMS current that can cause skin effect on a conductor, overload transformers, and nuisance tripping of circuit breakers. Keep in mind that single-phase nonlinear loads like switch mode power supplies and lighting ballasts cause zero sequence harmonic, third harmonic order, or triplen harmonic that, in a Y configuration, add up in the neutral conductor of a Y system that can lead to neutral conductor overload. In a delta configuration, get trapped in the delta of a delta system and can initiate magnetodestruction within the transformer in question. All these effects can lead to premature equipment failure. AccuSign is ideal to remove the high-frequency current from your distribution network, which in turn reduces the voltage distortion by stopping the flow of high-frequency current through your electrical network impedance. The reduction of total harmonic distortion current and total harmonic distortion voltage removes the stress on your distribution network. Power factor determines how well you utilize your power. It's the simple ratio of your real power over your apparent power. The general engineering practice or rule of thumb is to keep the power factor in an electrical installation above 90%. Why correct power factor? It can reduce utility bills by reducing your demand charges, which relates to your rate structure. It reduces apparent power, therefore reduces loading on your power transformer and distribution network. Reduces I²R losses. Electrical distribution systems have losses ranging from 2% to 5%. Correcting power factor reduces the losses by 1 to 2%. Reduces carbon emissions since we reduce the I²R losses. Improves voltage regulation by correcting the power factor. We reduce the loading on the network, therefore reducing the voltage drop across the network impedance. The most cost-effective way to correct power factor is to use automatic capacitor systems. They're typically installed at the main distribution board or at the MCCs. The Varset system is suited for small and medium-sized networks up to 1,500 kVA, and in large installations up to 5,000 kVA. Flicker level is discovered by using the short-term flicker coefficient, or PST. Flicker is caused by a series of voltage fluctuations and depends on both the magnitude of the fluctuation and the frequency of the fluctuation. Flicker is normally caused by large inductive loads. When a welder strikes an arc or an inductive load starts, they demand large amounts of inductive reactive power. That makes the voltage sag repeatedly, within milliseconds or seconds. Flicker may cause process downtime or generate poor quality products. Furthermore, utility companies may force the consumer to mitigate flicker if they're creating power quality problems on the utility distribution line. To solve flicker, the AccuSign Plus in power factor mode can be used to inject capacitive reactive power to counteract the inductive reactive power demanded. To be successful at correcting flicker, you must inject the right amount of reactive power within one electrical cycle. This makes the AccuSign ideal for the job because it's scalable. You install the number of units you need in parallel, and it can inject kVAR within 1/4 of a cycle, 4 to 5 milliseconds. Chronic undervoltage can happen because the consumer is at the end of a distribution line. A neighboring customer may be starting a large inductive load. A consumer may cause the sag with their own industrial process. Chronic overvoltage normally happens because the utility is switching capacitor banks on the medium voltage network. A large load is switched off within the client's facility or the medium voltage distribution line. The SureVolt automatic voltage regulator can take a voltage input ranging from plus 10% to minus 25% and regulate the voltage supply to plus or minus 3% within one cycle, making it an ideal solution for chronic voltage issues. Deeper voltage sags are normally caused by short circuit events and/or by operation of a utility recloser. For these deep sag events, the Sag Fighter is the solution. It can correct for 70% sag on 1 or 2 phases, or for 40% sags on 3 phases within 1/8 cycle, and boost the voltage back to 95% of nominal value.